Mm-hmm. Say that.
There was one question I'll ask you.
Ask it. Would you want to ask it at the end of the class or now? Whatever is
I'll ask in the end of the class.
fine. So you remember it, otherwise I'll forget. Fine. So
Thank you.
quickly, 2 points that I wanted to discuss. I'm not able to recall whether I've discussed this with you or not. Basically, who was the one who gave the concept of atomic mass? Who was the one who gave the concept of atomic mass?
Dalton.
Exactly. It was John Dalton through his postulates of the theory, wherein he was saying atoms of the same element will have the identical mass and atoms of different elements will have different masses. Through that, he gave the concept of atomic mass, and after that, scientists started measuring the atomic masses. Clear? Fine. So it was John Dalton who gave the concept of atomic mass. Fine. Next, I think I've already discussed this with you. The historical perspective of the atomic mass. Okay, what was taken as the first reference or the standard mass? What was taken as the unit first? Full carbon atom, right?
AMU. Yes, it's
Full,
carbon.
yes, full carbon atom. The mass of this full carbon atom was taken as 1 unit. Yes, the mass of this full carbon atom was taken as 1 unit. Then it was discontinued because when we were taking this as the reference unit, the mass of other atoms that we were getting were not in the whole numbers. They were in decimals, right? They were in decimals. And what did we want? We wanted the values to be more of whole numbers or at least near to whole numbers, not something more of decimals. Okay. So therefore, this was rejected. Then the second that was taken was the 116, the mass of naturally occurring oxygen. Naturally occurring oxygen, right? Then it was discontinued. Although there's no reason it's been written in the NCRT why was this discontinued. Acha, why was it actually taken? What was the reason behind taking 1/16th the mass of naturally occurring oxygen? Because because
Because one oxygen atom is like 12 carbon atoms.
Mhm. Why was oxygen taken? Why was oxygen taken first as the standard reference unit? Why? Because
Um,
oxygen is present almost in many of the compounds. It reacts very easily, yes, and it is there in much abundance. Those are the two reasons as to why oxygen was chosen or selected for having it as the standard unit. But then it was discontinued because of several reasons, and one of the major reason was that due to the presence of many isotopes of oxygen, there were inconsistencies in measuring the atomic masses for other atoms. Okay, that was the reason. Although that has not been mentioned in NCRT. Then the third and the final one, which was taken by the IUPAC, it was selected by the IUPAC, and that is 1/12 the mass of carbon 12 atom. Yes, this is nothing but 1 unit. Yes, this is nothing but 1 unit. Let's suppose if I'm measuring the mass of any atom, okay, any atom, and that comes out to be 3 times this, then I will say it is CU. Yes, simple. Any problem in this any problem in this concept? This is very important. Atomic mass. Any problem in this?
No.
Fine. And based on that, we can continue the. See, all of this is relative atomic mass, relative molecular mass. Yes. Why? Because we are taking it in relation to some other standard unit of standard mass that we have taken as the reference point or the unit. Okay. Therefore, we have it as the relative atomic mass or the relative molecular mass. What's the unit for the atomic mass now? What's the unit for atomic mass now? U. And what's the full form for this?
AMU.
Uh-huh. It's unified mass.
Atomic
Okay.
mass unit.
Earlier,
Sorry,
earlier,
unified.
yes. Earlier it was AMU, that is atomic mass unit, but now we have it as U, that is unified mass. Clear? Fine. Now molecular mass also in the
That's one.
similar manner. Let's suppose calculate the mass of this ethanol compound. Ethanol compound C2H5OH. Quickly. C2H5OH. Can you calculate the mass of this? Since it's a molecule, can you calculate the mass for this? Hmm.
Come on.
Why does the camera get turned off? Huh?
I'm plugging in my charger. 1 minute.
Okay. Ali, when is your exam? School exam?
It starts on 14th October.
Okay, so still time. Only 2 units, right? Like for chemistry, only two first chapters are there, right?
Yes, ma'am. Only first two chapters.
You are okay with that? Any problem, any confusion in that?
No, ma'am. They are all simple chapters.
Fine. So done. Calculated the mass for this C2H5OH. This is ethanol.
Yeah, ma'am.
How many different elements are here? Can you tell me how many different elements are here?
Four. Four different.
Name them.
Carbon, hydrogen, oxygen.
Which is the fourth one?
Three.
Which is the fourth one? Can I write? But your name is actually very. I cannot write that. Fine. So C2H5OH. So C into how many atoms of C?
Two atoms of C.
Okay. Then plus how many atoms of hydrogen?
5.
5 plus 1,
6.
6. Oxygen, 1. Okay. Therefore, what's the atomic mass for carbon atom?
12.
Carbon element? 12
No, what's
U
the?
into
That's four written, right? Oh,
where
four.
which is this? O into 1 because there's just one oxygen atom, right?
Oh, ma'am. I thought that H is four. Sorry.
Okay. This is H. Fine. So 1 U into 6 plus what's the atomic mass for oxygen element? 16 U into 1. Okay. What do you get? 24 U plus 6 U, that is 30 U plus 16 U. What do we get? 46 U. Correct? Fine. Now, I wanted to have one question here. And what is it? Just a second. Tell me uh, any element, name any element whose name is actually based on the place where it was discovered. Whose name and therefore the symbol is based on the place where it was discovered. But you know, these are all 1 mark questions, literally straight away from the NCRT. Copper discovered from Cyprus. What's the symbol here? Cu. Yes. Then tell me any one element whose name is actually based on its color. On its color. Yes. I will discuss two things here.
Carbon.
Yes, quickly.
Carbon.
Now, you people are not going through the NCRT. Huh? Umayma? Umayma, bachche, say that again.
Sulfur.
Sulfur. Ag, that is silver. Okay. Au, that is gold. Now, what's the actual name for Au? What's the actual name for Ag?
What my actual name of?
Silver and gold. How do we get these symbols as Au and Ag? Ag stands for argentum, that is silver, okay? And silver means nothing but color silver, okay? In Greek, this argentum means nothing but silver. Therefore, we call this as silver. Clear? And this aurum is nothing but meaning gold. It's based on the color, okay? And that is Au. We get Au from that. I hope the concept is fine.
Yes,
Fine.
ma'am.
And then,
But ma'am,
so,
sulfur is
yes.
yellow color.
Huh?
This what is the color of sulfur?
It is yellowish. Then it's not based on the color. Then you know there are some elements whose name are based on that. My question was that I think you are confusing it with a different concept. I was asking some specific elements whose name are actually based on their color. Sulfur is not based on that color. Are you getting the difference?
Yes, ma'am.
Fine. What is it? What's the symbol for sodium? Na.
N.
And Na. And what is actually Na stands for? Natrium. Yes. What's potassium? K. K stands for Kalium.
Kalium.
Fine. Iron, very important. Symbol for iron.
Fe.
What does it stand for?
Ferrum.
Ferrum. Okay. They are based on different languages. Okay. That's it. Greek or Latin words where they were first referred to as natrium, kalium, or ferrum. Therefore, we have their actual names as that, and therefore the symbols are also based on that. Fine. Now, coming on to the next part, just quickly remind me of this. I think I've told you this because we have 3 batches going on simultaneously. If we have ions, okay, one is the cation, the other is the anion. Okay,
Anion.
cation is the one which is positively charged, anion is the one which is negatively charged. And I think I would have told you this: metals generally are the cation. Okay, therefore they are generally positively charged, and non-metals are generally anions, and therefore they are negatively charged. Okay, when we have an atom, okay, when we have an atom, and if it gains a positive charge, what kind of charge? Positive charge. Okay, its name will not change. Its name will not change. I think I've discussed this with you guys. Yes.
Yes.
And when we are non-metal, the atom, and if it becomes an anion, the name will change. Example: sodium. Sodium atom changes to sodium ion. We will never say any other name for sodium ion. Okay. But when we have a chlorine atom, which is a non-metal, which gains a negative charge, therefore it becomes an anion, we will call it as chloride ion and not as chlorine ion. Okay. And what type of bonds are these? What type of bonds or compounds are these, which is formed by the combination of ions? By the combination of ions, first of all, ionic bonds or ionic compounds. Yes. Yes. And what was the other name? Electrovalent. Electrovalent compounds. Clear? I think all of this has been discussed. Now I'm coming on to the next part, next topic, which is very important. That is writing chemical formula. That is writing chemical formula. See, I wanted to discuss the basics for this right now, but since we are short on time, this will be discussed in the fourth chapter, inshallah. So we'll just quickly understand exactly what is it. But the basics of this topic is actually in the fourth chapter. Fine. So see, writing chemical formula. First of all, let's suppose, bachche, we have this thing. We have a compound. Okay, we have a compound. Let's suppose this is a compound. Yes, magnesium chloride. This is a compound. How do I get this? How do I get this? In this compound, can you tell me? We can clearly see that this one atom of magnesium bonded to two atoms of chlorine, right? If I'm writing Al2O3, what is this? I can clearly say that two atoms of aluminium bonded to three atoms of oxygen. Yes, these are formulae representing the composition for one molecule of these. What is the formula? Representing the composition, right? What is the formula? Representing a simple composition as to how we have gotten that compound. One molecule of that compound. Yes. Now, how do we get this? How do we get this? How can I say that in aluminium oxide, the aluminium oxide again, aluminium positive ion, but oxygen since negative ion, therefore I'm calling it as a aluminium oxide. Fine. So how do I know that I have two atoms of aluminium here bonded to three atoms of oxygen? How do I get this chemical formula? Okay. See, if you are able to understand, please understand this one point here very quickly, that what is happening in a chemical reaction. When we were discussing the chemical reactions in the second chapter, chemical changes, I told you there, basically some change in the chemical composition. Basically, sorry for the disturbance, there was an emergency. So, what was I telling? Yes, chemical composition. Yes, change in the chemical composition. Now, see, Let's suppose this is an atom. It is there initially, okay? How can it bond to some other atom? Let's suppose this is another atom, A and B. What is actually happening in the compound? Two different types of atoms are bonding together, right? Or what is happening in an element also? Two atoms are bonding together. In O2, what do we see? Two atoms are of oxygen are bonded to each other, yes? Why
Yes.
and how are they bonding to each other? That is the question. Why and how are they bonding to each other? That is the question. As in, what is the basis for their bonding? What is the basis for their bonding? Okay. And if they are bonding, how do we have a particular, let's suppose if aluminium and oxygen are bonding, therefore they are forming aluminium oxide. This is very obvious. If aluminium and oxygen are bonding, definitely they are forming aluminium oxide. But how do I know that when aluminium and oxygen are bonding, they have a particular ratio proportion, that is two atoms of aluminium bonded to three atoms of oxygen? How do I know that? Yes. Or when magnesium or chlorine they are bonding, how do I know that one atom of magnesium is bonding to two atoms of chlorine? Yes. Now for that, you have something which is called as valency, which is called as valency. Ali, are you getting this picture? Any problem? I
No,
hope you're in the
ma'am.
class.
No problem.
Yeah.
Yes.
So valency basically means how many bonds can the atom form? How many bonds can the atom form? Okay. How many bonds can the atom form? Let's suppose, Ali, you can buy 10 pencils. I don't know, very weird example, but just understand this. You can buy 10 pencils. Okay, Ali. Now you go on to one shop. You go on to one shop, okay, where where only in one shop they can give you 10 pencils. Where only in one shop you can get 10 pencils. This is the first scenario, okay. Now the second scenario is that you go to another shop, okay. And second scenario where one shop can only give you 5 pencils. So definitely you will have to go two times. Yes, you will have to go two times. Are you getting this? Now
Yes,
let's
ma'am. I'm
suppose you
getting
have
that.
the third scenario. Third scenario is that you go to a shop where they are only able to give you two pencils at one time. So don't you think you will have to go five times? Are you getting?
Yes, ma'am.
So therefore, if we are talking about one atom, the maximum capacity, the maximum number of bonds that it can form is called its valency. The maximum number of bonds that it can form is called its valency. Okay. Now, if it is bonding to different atoms based on their maximum capacity, we are having a different combination. Yes. Based on their different capacities, we are having the formula. Example C. We will quickly see it here. Um, mm, let's suppose we are taking aluminium. Okay. We are taking aluminium, and I am telling you here that aluminium has the valency is +3. That means one atom of oxygen needs to form three bonds. Needs to form how many bonds? Three bonds. Okay. Now see, if it is bonding with chlorine, chlorine, one atom of chlorine can only form one bond. One atom of chlorine can only form how many bonds? How many bonds?
One.
One bond. Okay. So definitely I'll be
One.
needing three chlorine atoms. Yes.
Yes.
Three chlorine atoms. Yes.
Yes,
Let's
ma'am.
suppose if it is bonding to nitrogen. If it is bonding to nitrogen, now one atom of nitrogen can form three bonds. This is a very weird combination, but just to explain that one atom of nitrogen can form three bonds. Okay. So definitely here only one atom would be needed. Here only one atom would be needed. Yes. Now,
Yes,
if I am
ma'am.
going to any other atom, that is oxygen. We are still talking about the bonding of aluminium itself, which has a maximum capacity of 3. That is the valency of aluminium is 3. Okay. If I'm talking about oxygen, one atom of oxygen can form a maximum of two bonds. So
Two
how will they
bonds.
form? They will say, okay, you take three atoms of oxygen. Okay, I'm taking two atoms of aluminium. Therefore, we can have the bonds. Okay, one is not enough. Okay, one is not enough definitely because one is having three bonds. Okay, aluminium needs three bonds. One atom of oxygen is able to give two bonds. Now, if we take two atoms of oxygen, we are having four bonds. Still, aluminium is just able to have three bonds, right? So if we take two atoms of aluminium and if we take three atoms of oxygen, we are able to have a bond there. Are you getting this? How? Let's see. Let's suppose, bache, we have two atoms of aluminium. Please try to understand this, okay? Two atoms of aluminium. See, just go by this formula, Al2O3. We are having two atoms of aluminium bonded to how many atoms of oxygen?
Two atoms. Three
Three
atoms.
atoms of oxygen, okay?
Two.
So, and I just now told you that
Three,
each
yeah, three.
aluminium, each aluminium atom can have how many bonds do they need? Three.
Three.
Okay. So these three dots represent the three bonds that each aluminium atom wants to form. Okay. Just see this, but please understand this. Each oxygen atom can form how many bonds? Two bonds. Okay. Two bonds. Now see, one, two, one, two, one, 2. Are you getting this? Therefore, in this combination, they are able to have the bonds, all of the bonds satisfied also for aluminium and also for oxygen. Also for aluminium and also for oxygen. If I take this scenario, let's suppose I just take one aluminium atom, okay, and I take one oxygen atom. So you see, one bond is still left for aluminium. Yes, one bond is still left for aluminium. But then if I take two atoms of oxygen, one bond is still left for oxygen. Yes, one bond is still left for oxygen. Then I take two atoms of aluminium with 3 valency. Okay. So now 2 bonds are still left for aluminium. Therefore, what will I do? I will take 3 atoms. Okay. And now we see that all of them are satisfied. Are you getting this? Are you understanding this?
Yes,
Yes.
ma'am.
Yes, ma'am, I understand.
So what is it that we're talking about? That we're talking about valency. It is valency that is the maximum bonding that each atom of a particular element can have. Each atom of a particular element can have the maximum number of bonds, and that is called as the valency. Okay. And based on the valency, we are getting different compositions when they are bonding with different atoms. When they are bonding with different atoms. And that is nothing but chemical formula. That is nothing but chemical formula, because in compounds we see, or in elements also we see, that two different atoms are bonding together, right? And specifically we have these formulas for the compounds here. Okay, no need to go into this thing for elements. Just assume that in case of compounds, what are we doing? We are having two atoms together, right? Two or more than two different atoms bonded together. How are they able to form those bonds? Based on their valency, based on their
Valency.
valency. Is it clear? Is it clear? Okay,
Yes, ma'am.
fine. And a very quick concept here, that is valency is related to the charge. Valency is nothing but the charge. Okay, valency is nothing but the charge. And whenever we have a charge on the species, does that become the ion? Does that become the ion? Yes. So therefore, what are we saying? Ions or atoms or species with a particular charge on them, which is nothing but valency, they are reacting with each other to form the bonds. To form the bonds. Clear? Clear? An example, see. How do I get the chemical formula? I will use the valency and the symbol. I'm explaining you it. Please see. Let's suppose I am saying that I have to have the chemical formula. You understand chemical formula, right? I've already told you that it is representing the chemical sorry, it is representing the chemical composition, right? Of two or more than two different elements who have actually bonded together in a particular proportion, right? That's chemical formula. Now, if I have to get the chemical formula when I'm saying sodium is reacting, could you tell me the symbol for sodium? And we are going to use symbols for our convenience, not the full name. Symbol for sodium,
Na.
Na. And then I'm saying it is reacting with oxygen. So the symbol for oxygen,
Oh,
O. Okay,
okay.
then fine. Then the second step is that I will write their respective valencies, and we will see how do we get that. I will write their respective valencies. Okay, the valency for sodium is 1 plus 1. I will tell you why. And the valency for oxygen is -2. See, +1, -2, plus and minus basically are indicating nothing but just that when they are forming the bonds, what type of charge do they develop? So sodium being a metal, I already told you this, that will develop a positive charge. Yes, will develop
Yes.
a positive charge. So this positive is telling you nothing, just that this atom will be developing a positive charge because of the bonding. Yes, in that bonding, something is happening because of which charges are developed. In that bonding, something is happening because of which charges are developed. Okay, and this -2 is indicating what? That it is becoming an anion.
Negative.
Anion. Yes, good. Now this is the second step. The third step is that I will just crisscross them. Okay, Na2O. We get the formula for sodium oxide. Sodium oxide.
Oxygen.
And see, and if you are able to understand this, how many atoms for sodium do we have in this formula?
One atom of oxygen.
Sodium, which is sodium.
Sodium. Two.
2. And one atom of
Oxygen.
oxygen. See, I'm drawing this sodium atom. 2 atoms of sodium, right? 2 atoms of sodium. And what's the valency for sodium? 1. That means one bond. Each sodium atom can only form one bond. Yes. and we have 1 atom of oxygen. How many bonds can oxygen form? 2. Yes. Don't you think to
bonds.
suffice the valency of oxygen, if I'm bonding it with sodium, I will be needing 2 sodium atoms to suffice for the valency of oxygen here? Yes. The same
Yes.
point, if you are buying 10 pencils and if one shop is able to just give you 5 pencils, you will buy twice there, right? Ali, yes?
Yes, ma'am.
So is this clear? Is this clear? What are the 3 steps? Just 3 steps. You will be writing the symbols for different elements between which we are having the combination, okay? For which we are having the chemical formula or the compound. Second, you will be writing their valencies. You will be writing their valencies, okay? Third, you will just crisscross them. You will just crisscross them, fine? Now see, two important, very important points here. Let's suppose we have magnesium and oxygen reacting. Okay, we have magnesium and oxygen. So first of all, tell me the name of the compound. It will be magnesium oxide. Yes, magnesium and oxide. It will be magnesium oxide. Yes. So the valency of magnesium is +2. The valency of oxygen is -2. Yes. Can we just crisscross them? Can we just crisscross them? So we will get Mg2O2. Now both of them, because obviously it will get cancelled. So what are we getting? MgO. What are we getting? Mg. Clear?
Yes, ma'am.
Yes, ma'am.
Fine.
Yes.
And the third important point here is that, see, let's suppose we are just having atoms. When we were talking about ions, we talked either there could be a single atom with a charge. There could be a single atom with a charge. Example, Na plus 1 atom with a charge. Example, Cl minus 1 atom with a charge. Yes. Or there could be polyatomic ions, right? That is a group of atoms with a net charge on them. A group of atoms with a net charge on them. Oh, ma'am, are you okay?
Yes, ma'am.
Okay. Group of atoms with a net charge on them, okay, and they were called as the polyatomic ions. Basically those are molecules with have with a charge on them. So what is the example for that? See, sulfate. This is a group of atom. Okay, what's the net charge on it? -2. -2. Okay, let's suppose I am reacting sodium and sulfate. Now what will I do? See, what's the valency for sodium? +1. What's the valency for sulfate?
Ma'am?
Yes.
-2. What's the charge on sulfate? -2. Yes. Ali, what's the problem?
Yes.
Okay, now see,
I didn't hear you,
if
ma'am.
I have, okay, fine. If I have to now make a chemical formula for these, what will I do? I will crisscross them. I've written the symbols, I've written the valencies. Okay, see, but see, we are not concerned with this. I'm just telling you here to, explain you. Otherwise, we are not really concerned with this. So, what we will get? Na2 SO4 whole 1, right? Whole 1. What is it indicating? I will take any other example for you to understand this. Let's suppose I'm having aluminium and sulfate. So 3 and 2. Yes, 3 and 2. What will I get? Al.
Al2.
2 in the subscript. This is called as writing in the subscript. Okay. You have learned this in atomicity. When we write it in the subscript, that is basically indicating the number of atoms there, right? So Al2.
Yes, ma'am.
Then Al2.
SO, SO7.
Yes. 4 plus 3, 7. Okay, I can write it. But see, that is wrong. See, what will I do? See. Please understand this concept here. Please, this is very important. What is it that we were doing when we were reacting sodium and oxygen? We were wanting the number of atoms that can suffice the valency of oxygen, yes. Or what we were doing when we were reacting aluminium or oxygen, we were wanting the number of both the atoms which can suffice each other's valency, yes.
Yes.
Yes. Now see, sulfate, that is SO4, has a net charge on it. SO4 raised to the power -2, net charge on it. Okay. So therefore, what are we doing? What are we doing here? See, what we will get here is Al2. This whole will have this 3, right? This whole because had a charge of -2. Therefore, this whole will have a Al2SO4 whole thrice. Whatever is there in the bracket will have this atomicity of 3 here, or the number of these polyatomic ions will be 3 here in this compound. Is that clear? Is that clear?
Yes, ma'am.
Ali,
Yes,
clear?
ma'am. It's clear.
Fine. So therefore, if we are to read this, how many elements are involved in this compound? Very quickly, elements. Tell me the correct answer. I'm not asking the ions. I'm asking the elements.
3.
3 बच्चे, aluminium, sulfur, and
Oxygen.
Oxygen.
Had I been asking about the number of ions, you will say 2. That is aluminium +3 and sulfate -2. Yes.
Yes, ma'am.
Clear.
Yes.
Now, if I ask you to tell me the number of atoms here for each element, aluminium, how many atoms in this one molecule of this compound?
Yes. 2 atoms.
2 atoms. How many atoms of sulfur here?
4.
4.
How
Total
many
in the
atoms of
Oh no, 1.
but this 3
1
is for
atom of sulfur.
just a second. Just a second. No, that's wrong. Aluminum is right. See, whenever we are talking about anything that is, in the bracket with the whole, when we are saying whole of it, okay? See, this 3 is for every atom or every element which is present inside the bracket, okay? Which is present inside the bracket. So see, 3 is also for sulfur and 3 is also for oxygen. Now I already told you, if we have multiple numbers for a particular element, we'll just multiply them, right? We'll just multiply them. I think that has already been discussed. So for sulfur, what do we see? 1 here and 3 here. Can I say 3 atoms of sulfur?
Yes, ma'am.
Ali, yes? Clear?
Yes, ma'am.
Yes or no? Yes. And for oxygen, tell me how many atoms in this one molecule? Tell me the
12.
correct answer. 12. Excellent. 12 for oxygen. Clear, Ali?
Yes, ma'am. Understood, ma'am.
Fine. Now I'm giving you one question. Magnesium and nitrate. Okay, magnesium and nitrate. Magnesium has a valency of +2, nitrate has a valency of -1. Okay, tell me the formula. Okay, tell me the chemical formula and tell me the number of elements and atoms present in them. Quickly. Ali, bacho, quickly. Umema, quickly. What is the formula that we get? Ali, are you doing it?
Yes, ma'am, I'm doing.
Yes,
Done,
but
ma'am.
just tell me the formula. Yes. What's the formula that you have gotten?
Mg into NO3 into 2.
We will never say into, okay? We'll just say MgNO3
Okay.
whole twice. MgNO3
Whole
whole twice.
twice.
Okay. Umema, is this the same thing that you have got?
Yes, ma'am.
Fine. Now this is magnesium nitrate because what were the two ions which were reacting? Magnesium, name will not change even if it's in the ionic form, and nitrate. Okay, NO3 - 1 is called as nitrate. Clear? Now this is fine. Now this is one molecule. How many elements are present in this one molecule of this compound?
3.
3.
Name them. Magnesium, nitrogen, and
Magnesium, nitrogen, and
Magnesium,
oxygen.
nitrogen, and oxygen.
how many atoms of the magnesium in this one molecule?
1.
1.
One. How many atoms of nitrogen? Think and then answer.
2.
Two. How many atoms of oxygen?
6.
6.
6. Now tell me the number of atoms present in this. Tell me the correct answer, bache, okay? 7 MgNO3 whole twice. Basically, what is representing this? I mean, what is it that this is representing? 7 molecules of magnesium nitrate, yes? 7 molecules of magnesium nitrate. Fine. Ali, how many atoms of magnesium?
1.
I'm not going
So
ahead.
it's 7, 7, 7. 7
Why did
atoms
you
of
say 1? I
magnesium.
just want to know that. Why did you say 1?
I thought you were asking about the formula.
Hello? Am I audible now? Is it better now?
Yes, ma'am.
I want to know why did you say 1 first? That is what I
I
am
said
more
1
interested in.
first because when I found out the formula, the atoms in the formula were magnesium
Okay.
atoms were only 1. So
Okay.
that's why.
Because the molecule number was 1, right? Because the molecule
Yes.
number was 1. Now, if I'm talking about 7 molecules, how many magnesium atoms?
7 magnesium atoms.
7 magnesium atoms. How many nitrogen atoms?
14.
14. No, not 14. There will be 2, then yeah, 14, 14.
How many oxygen atoms?
42.
42.
Now see, all of this, right? See, 7 is for magnesium, 7 is for nitrogen, 7 is for oxygen, right? 2 is for oxygen, 2 is for nitrogen, 3 is only for oxygen. Therefore, just multiply all the numbers concerned with every element. I think this should be clear. I think
Yes.
this should be clear, right?
Yes,
So,
ma'am.
how do we get hydrogen? How do we get sulfuric acid? How do we get sulfuric acid? That is H2SO4, right? That is H2SO4.
Yes.
H2SO4. Yes. So
Yes,
let's
ma'am.
suppose here hydrogen is having a charge of +1. SO4 -2. What do I get? H2SO4, right?
Yes, ma'am.
Yes.
Yes, ma'am.
Fine. Fine. Should I come to the NCRT? Any confusion? Any problem here?
No, ma'am.
Tell me the
Ma'am.
formula for calcium chloride. Tell me the formula for calcium chloride when the valency of calcium is 2. Very quickly. Calcium chloride. I've already told you the valency for chlorine. You know that.
Ma'am, I forgot what was the valency of chlorine.
What charge does chlorine atom gain? -1. Yes. Chloride ion.
Yes,
-1.
ma'am.
So
Ma'am, can you
calcium.
write calcium chloride?
Acha, name.
Okay.
Okay. I did not. I did not understand what are you asking for, bache? Calcium with a charge of valency of +2. Chlorine with a valency of -1. Yes. So what do we get? Ca.
Yes, Cl and then whole 2.
But you see, when we are just having one element or one atom here, okay? I mean, one element, there's no need to say whole because we know it's for one element, specifically for one element. It is specifically when we are having this thing, polyatomic ions, right? With a net charge on them. Then we say whole. Example, see. Calculate the formula for calcium hydroxide. Hydroxyl ions with a charge of -1. Calcium, I already told you. Tell me the formula for calcium hydroxide. Very quickly. Very quickly. Yes, Acha.
CaOH twice.
Mama, your answer? Ca?
CaOH2.
Here we are going to say it like CaOH whole twice, okay? Because see, what is this? This is a polyatomic ion, but so please get it. There's not just one atom here in the ion. It's a polyatomic ion, O and H, both of them having a net charge of -1. So whenever we are going to have this, polyatomic ions in the combination in the reaction, okay, then we are going to have it as the formula as whole, whatever number we are getting after that, okay? I hope that answers your concept. That clears your concept, okay? Ali,
Yes.
respond. So let's quickly go through the NCRT, बच्चों. See, very quickly. Already that has been explained. Chemical formula of a compound is a symbolic representation of its composition. Understood? Chemical formula of different compounds can be written easily. Okay, what do we need to do? We need to learn the symbols and the combining capacity of the elements. What's the combining capacity? The maximum capacity, right? And what is it? Valency. What is it?
Valency.
Yes. Now see. The combining power or the capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. I've already explained you this concept. Any problem in this part here? I've already told you in what
No,
manner
ma'am.
are they going to combine. I hope this paragraph is understood.
Yes, ma'am.
The valency of the atoms of an element can be thought of as hands or arms of that atom. Now see, this is just an example. This example here. Please go through this. I'm not interested in going through this. I've already told you through a different example. Okay. Now see, the valencies of some common ions are given in this table. We will learn about valency. See, sodium Na+1. +1. If plus is there, and I mean no number is written, I've already told you in chemistry that means 1. Okay. So plus means +1. Plus means +1. Had it been written +2 means the valency is 2, right? If it is written just plus means the number here is 1. Therefore, the valency is
1.
1. If for chlorine, I'm writing like this. We will always write chloride ion like this. What's the valency of chlorine here? What's the valency of this? 1.
Negative
Or,
1.
yes.
Yes.
Ali, clear? Ali got stuck. Okay, fine. So these are the polyatomic ions. This is ammonium. NH4 raised to the power plus 1. NH4 raised to the power plus 1. Yes, see, there's no number written there, but there's 1 plus sign. Therefore, it is indicating plus 1 charge. Okay, therefore, the valency becomes 1. Hydroxide ion, OH minus 1. Nitrate, NO3 minus 1. Hydrogen carbonate, this is full, HCO3 minus 1. HCO3 minus 1. Carbonate is CO3 minus 2. Carbonate is CO3 minus 2. Sulfite, sulfate, phosphate. Write it for sulfide also. Sulfide they have written. Okay. Sulfide they have written. Okay. Now, important point here is that, bachcho, please, two important points. Copper and iron. They do not have one valency. They show two valency. They show two valency. Copper can also show plus 1. Copper can also show plus 2. Iron can also show plus 2 and can also show plus 3. Okay. If copper is present in the plus 2, see, these are metals, right? They are becoming cations. Definitely their name should not change. But since we need to differentiate between plus 1, plus 2, and for iron between plus 2, plus 3, we have different name for them, okay? When copper is present in the plus 1 form, it is called as cuprous. It is called as cuprous. And when copper is present in the plus 2 form, it is called as cupric. It is called as cupric. Iron when present in the plus 2 form, ferrous. Ferrous, okay? When plus 3, ferric. See, the greater is ric, and the smaller one is as. Okay, clear?
Yes, ma'am.
Ali, is
Yes,
it clear?
Yeah.
Quickly tell me the formula for cuprous oxide, or both of you, cuprous oxide. Now, valency you can understand by yourself. Cuprous and oxide, oxygen is minus 2, okay? The valency for oxygen is 2. If I'm saying cuprous, what will be the valency?
Plus 1.
1 plus 1.
Tell me the formula. So CuO plus 1 minus 2. What do I get? Cu2O. Yes.
Yes, ma'am.
And if I'm saying for cupric oxide, bacho, cupric oxide, so we have Cu in the plus 2 form, yes? Oxygen in the minus 2 form, that's all. So 2 cancel each other, we will get CuO. I hope that is clear. Fine.
Yes,
Any
ma'am.
problem, bacho? See,
No, ma'am.
I've already explained you the rules. You can please go through them. I've already explained you each and everything. If there's any problem, you can ask it. Okay. So the
Okay.
magnesium chloride, Al2O3, we have already practiced all of them. HCl, both of them having a charge of plus 1. Clear? So that's it. I've already told you this. NaNO3, this is sodium nitrite. Na with a charge of plus 1, nitrate with a charge of minus 1. Now this is a polyatomic anion. But since here we just have 1, there's no need to have the bracket. Because what are we having? 1. See, even if we have the bracket here, see, I mean, even if I write the bracket and if I'm 1, we still have nitrogen as 1 atom only. We still have oxygen as 3 atoms only, yes? Because if I'm writing like this, what does it mean? 1 atom of nitrogen and 3 atoms of oxygen. I think that is clear, yes? So no need to write it in the bracket. When the other atom or the element is having a charge of plus 1. Is it clear? Clear?
Yes, ma'am.
Example, I'm saying sodium sulfate. Sodium. I will not write it sodium and sulfate as whole one. No. Even if I'm writing it without the bracket, that is understood. Na2SO4. Okay. Ali, Umaima,
Yes.
clear? But see, when we
Yes.
are having this other element with a charge of 2, that we will write it. Okay. Other than 1, we are indicating it as OH2. Yes. OH whole twice.
Yes, ma'am.
So all of that has been discussed, and I think I've already discussed this molecular mass and the formula unit mass. The chapter is completed from my side. Inshallah, in the next class, we'll be starting the 4th chapter. I hope there should be no confusion in the chapter. I've tried to explain all the concepts with much efforts. If there's any confusion, please feel free to ask me. Okay.
Okay, ma'am.
I don't know. Phosphate has, yes, phosphate is okay. You will have to practice all of these. You cannot, like, you can learn them, but it will only be there through practice. Okay. Practice. Okay. Quickly see. What is this? Aluminium sulfate. I've already told you, just see the ions and then tell the name. Aluminium sulfate. What is this? I've already explained you this. What is this? K2SO4. Quickly. K2SO4. K is what? K is what? Symbol of K stands for
Potassium.
sulfate. SO4. Yes. So what will be the